Example 1, using the Pythagorean theorem, Math, Mr. Williams. Find the value of x, then tell whether the side lengths form a Pythagorean triple. All right, so first thing we need to do is write down the Pythagorean theorem. So c squared equals a squared plus b squared. So the c squared is going to change into x squared, and that's going to equal our a value, which is the 5, squared, plus our b value, which is the 12 squared. Now, so you could think of this as the shorter side, the longer side, and the diagonal. Okay, so let's go ahead and do our math here. So we have 5 squared. It's going to get us 25 plus 12 squared will arrive at 144. Let's go ahead and add those up. X squared equals 169. And that's a perfect squared number. So what we're going to do is we're going to go ahead and find the square root of each side, giving us x, because the squared and the square root cancel, equals 13. That is our answer. So it does form a Pythagorean triple because the numbers are integers. Example 2, using the Pythagorean theorem, Math of Mr. Williams. Find the value of x, then tell whether the side lengths form a Pythagorean triple. All right, so the first thing we need to do is write down the Pythagorean theorem. So we have c squared equals a squared plus the b squared. And we now know the diagonal, so it's going to be our c. We know the short side is going to be our a. So now we just have to find the b, or the x. So let's go ahead and plug our numbers in. So we know that it's 14 squared equals 7 squared plus b squared. If we multiply that out, we know 14 times 14 will give us 196 equals 7 times 7 is 49 plus x squared. Now we're going to go ahead and subtract 49 from both sides, canceling out the 49s on the right, leaving us 147 equals the x squared. So let's go ahead and take the square root of both sides, focusing only on the positive root because it doesn't make any sense to have a negative number there. On the left, we'll have the square root of 147, which equals just x because the square and the square root cancel each other out. Now, what we're going to do is we're going to use the product property and we're going to break up 147 here, and that will be the square root of 49 times the square root of 3, because 3 times 49 will be 147 equals x. And we know the square root of 49 being a perfect square is going to be 7. So now we have 7 square root of 3 equals x is our answer. And because 7 square root of 3 is not an integer, the side lengths do not form a Pythagorean triple. Example 3, verifying right triangles. Math of Mr. Williams. Tell whether each triangle is a right triangle. So the first triangle is 8, 7, and a square root of 113. So we can presume that this could be our right angle, making this our shorter side, a long side, and this is our diagonal then. So let's go ahead and write down our Pythagorean theorem here. C squared equals a squared plus b squared. And our c would be the square root of 113 squared equals a, short side, which would be 7 squared, plus b, which is 8 squared. So we know that if we square something that's already square rooted, it cancels itself out, giving us 113 on the left. That's equal 7 squared, and we know 7 squared will be 49, plus 8 squared is 8 times 8, so 64. All right, so 113, does it equal 49 plus 64? It does. So the triangle here is a right triangle. All right, on to B. So we identify our diagonal, our shorter side, our longer side here. So let's go ahead and take care of this now. So we have 4 square root of 95, which needs to be squared, equals our short side, which is 15 squared. Long side is 36 squared. All right, let's break up the 4 square root of 95. We're going to distribute that squared to both the 4 and the 95, giving us 4 squared times square root of 95 squared equals 15 squared will give us 225 plus 36 squared will get us 1,296. So 4 squared will arrive at 16. And anytime you have the square root and a square, they cancel each other out. So that's going to be times 95 equals the 225 plus the 1,296. All right, 16 times 95, we arrive at 1,520. And does that equal 225 plus 1,296? The answer is no, it does not. So this triangle is not a right triangle. Example 4, using the Pythagorean Theorem. Math, Mr. Williams. Find the value of x, then tell whether the side lengths form a Pythagorean triple. All right, so let's identify everything here. We have our short side, we have a long side, we have the diagonal. So let's go ahead and plug in our formula. So we have c squared equals a squared plus b squared. C being the x, so x squared has to equal our short side, which is 7 squared, plus 11 squared. So x squared equals 7 times 7 is 49, plus 11 times 11 is 121. Now we add that up, giving x squared equals 170. Let's see, now we got to square root both sides. Square root of x squared, does it equal the square root of 170? Yeah. So let's go ahead and cancel out the square root and the square, giving us x equals, let's go ahead and break our square root of 170 up here. So we have square root of 10 times 17 to get to 170. Let's break up to 10 because 17 is a prime, giving us x equals the square root of 2 times 5 to get that 10 times 17. Now it looks like there's nothing that's going to be pulled out all the way, so let's go ahead and type that in decimal, see what we get. And in that case, we do get x equals 13 and 38 thousandths. Okay, so this one does not form a Pythagorean triple. All right, on to B, write down our formula. So we have c squared equals a squared again plus b squared. Do our substitution here. So this time we see our diagonal is still the x. See our short side is going to be the 16, and our longer side is 30. So we have x squared equals 16 squared plus 30 squared. So x squared comes down. 16 times 16 will get us 256 plus 30 squared will be 900. All right, let's add the right. So we have x squared equals 1,156. And now we square root both sides. The square and the square root cancel, leaving us x equals 34. So since 34 is an integer, this forms a Pythagorean triple. All right, example 5, modeling real life. Math of Mr. Williams. Television sizes are measured by the lengths of their diagonals. You want to purchase a television that is at least 40 inches. Should you purchase the television shown? Explain your reasoning. So in this case, I see that we have a long side, we have the short side, but we're missing the diagonal here. Let's go ahead and write down our Pythagorean theorem. So we have c squared equals a squared plus b squared, and we know our c squared is going to equal the short side squared, so 20.25 squared plus our long side, which is 36 squared. So we have 20.25, and let's go ahead and square that. That'll get us quite the long decimal here, plus Now we have 36 squared, which will get us 1,296. We'll add those two numbers up. We arrive at 1,706 with a decimal, 0.625. Now we're going to go ahead and square root both sides here. So we have our C, because our square and square root cancel, equals 41 inches and 3/10. So we can see 41 inches and 3/10 of an inch is greater than the 40 inches that was our least requirement. Should we purchase a TV? Yes, because 41.3 inches is greater than 40 inches.